Lesson 6.7, Graphing Inequalities. In this lesson, we're going to be discussing compound inequalities. And a compound inequality is like a compound sentence. It's an inequality that's joined with an and or an or. The first type of compound inequality that we have is called a conjunction. A conjunction is a math sentence combined with the words and. They're also known as intersections. And just like if you have two roads and they have an intersection, that's the place where they meet. It's also the part of the both roads that they have in common. A conjunction is the part of the inequalities that overlap. So you have two inequalities joined with the word and we're looking for the part that overlaps, the numbers that the two inequalities have in common. The second type of compound inequality is called a disjunction. Disjunction is a math sentence that is combined with the word or. It's also known as a union. And just like if you think of a union in non-math life, a union is a marriage, or a union as in the union of the states in the United States. It's the total of both inequalities. So everything that they have in common as well as everything that they don't have in common all combined together. So we'll start with conjunctions, and conjunctions may or may not have the word and in them. Here are two examples of conjunctions. You'll see that the first example has the word and the second example does not. They're both conjunctions. So we're looking for the intersection or the overlap. And in order to solve these, we solve them the same way we would solve equations. There's a little difference over here, but in our first example, we have two inequalities and we'll solve them separately. So in our first one, we'll add 5 to both sides. This will give us 3x is less than 15. Then we'll divide both sides by 3. And this will give us x is less than 5. This one is completely solved. Now we'll come to the second one. To start, we subtract 11 from both sides. That will give us 2x is greater than negative 14. We'll divide both sides by 2. And that will give us x is greater than negative 7. Now to keep this as a conjunction, when we write our answer, we write that with the word and in the middle. So here's our solution to this set of inequalities. If it's written without the word and, what you have is essentially two inequalities put together that the expression portion or the variable portion are the same. This is 6 is less than 3x plus 4 and 3x plus 4 is less than or equal to 31. And when we solve these, if we come back and we look at our first example, we have two sides to the inequality, 1 and 2. So anything we did to this side, we also do to that side. In this combined format, we don't have two sides, we have three sides, 1, 2, and 3. So anything we do to the one, we have to do to the other two as well. So whereas before you subtracted 11 twice, here we're subtracting 4 3 times. So anything you do to one part, you have to do to all three. So let's work on solving this. Okay, our first step is going to be to subtract 4. And again, we don't have two sides, we have 3. So we subtract 4 in 3 places. That gives us 2 is less than 3x is less than or equal to 27. After we've done the subtraction, we're going to divide all three sides by 3. 2 doesn't divide by 3, so we get the fraction 2/3 is less than x is less than or equal to 9. And in this format, we don't have to use the word and. We just present it exactly the way it turns out. Well, when we work with inequalities, we often have to graph them. So we need to learn how to graph the conjunctions. So if you recall, in our first example, we had two solutions. X is less than 5 and x was greater than -7. If we were to look at each of these individually, x is less than 5, x is greater than -7. To graph x is less than 5, I put the open circle on the 5 because we're less than. And then I graph, or shade rather, all of the numbers that are less than 5. Everything on this side of the number line is true. Now if I want to graph the solution x is greater than -7, I put an open circle on -7, again because I only have a greater than, not an or equal to. And then I shade every number that'll make that true. So all of the numbers that are greater than -7. When we look at this, x is less than 5. That means none of these values are true. Here we have x is greater than -7. That means none of these values are true. When we put these together, these untrue values will still be untrue. So our x between the two inequalities is the same x. So if x has to be less than 5, 10 won't work. Or if x has to be greater than -7, -9 won't work. So in order to graph the actual conjunction, we need to look at the combination of the two graphs. And we shade the area in between. This is the part that is true for both inequalities. So this is the solution. This is the graph for x is less than 5 and x is greater than -7. So how do we graph this without having to graph all three graphs to figure out which area to shade? Well, let's get our solutions back. Okay. What I recommend is we look at each individually. I said x is less than 5. I'm going to make my open circle on 5, and then I indicate for less than that I would need to shade in this direction. So this would all be shaded. And then I have x is greater than -7, so I put my open circle on -7. And everything greater than -7 is this way. And when my arrows point towards each other, like they are here, I know that I need to shade the area in between. So once I have this set up, I come in and I shade what's in between. Then I don't have to make all three of those graphs that we just looked at. I can do it all on one graph. Now to graph our second example, we had 6 is less than 3x plus 4, which is less than or equal to 31, which gave us, wrong color, sorry about that, gave us 2/3 was less than x was less than or equal to 9. Now to graph, I'm going to apply a similar technique. I need to find 2/3, which 2/3 is about right here. And I'm going to put an open circle on 2/3, and then I have 9. I'll put an open circle on 9. Now x is in between 2/3 and 9, and that tells me that I need to shade in between 2/3 and 9. I don't have to do a lot of work with this. that part right there indicates to me where to shade. So I'll come in and I will shade between 2/3 and 9, just as X was lying. Okay, here are some more examples. What I would like you to do is pause the video, try these, try graphing them, and then when you're done, unpause the video and we'll go over them and you can look at your work. So let's check and see how you did. You should have gotten 0 was less than X was less than or equal to 5. And n is greater than or equal to -3, and n is less than or equal to 3. On the graphing, you should have an open circle on 0, a closed circle on 5, and have shaded in between, and closed circles on 3 and -3, and have shaded in between. The next thing we need to discuss are disjunctions. And again, remember, disjunctions are used with the word or. There are no combination disjunctions, so you will absolutely see the word or if this is a disjunction. Whereas and you had 2 options, with or you only have the 1 option. So it'll look similar to this. You'll solve each inequality separately. So for our first step, we'll add 10 to both sides to give us 8x is greater than 48. Then we will divide both sides by 8 to give us x is greater than 6. Then we'll come to our second inequality. We will subtract 5 from both sides, giving us -3x is greater than or equal to -3. We will divide both sides by -3, and don't forget we're dividing by negative, which means we need to flip that inequality symbol, which will give us x is less than or equal to 1. Writing this out, you'll have x is greater than 6 or x is less than or equal to 1. Don't forget to put the word or between the two. In order to graph a disjunction, we'll do a similar technique as we did before. Okay, we had x was greater than 6 or x was less than or equal to 1. So let's graph x is greater than 6 and x is less than or equal to 1 separately first, and then we'll graph our disjunction together. Starting with x is greater than 6, I need to put an open circle on the greater than, on the 6, and then I shade the side of the graph that is greater than 6. Okay, to graph x is less than or equal to 1, I put a closed circle, and I graph the part that is less than or equal to 1. Now you'll notice that these graphs do not have an overlap like we had before. Now you'll remember also we had said that the word or indicated a union, which indicates combining, not overlapping. So to graph this disjunction, or the or one, putting these on both the same graph, I would draw my arrow to shade that way, and I would draw my arrow to shade this way, and when my arrows point in opposite directions, I shade in opposite direction. So I will shade this direction and this direction. Very occasionally you will get a disjunction that the arrows point to each other. When that happens, you shade the entire number line. You have all numbers. So here are two more examples. Again, I would like you to pause the video, work these out, graph them, and then come back on and compare. So now we're back and I've solved the equations, the inequalities, and I have them graphed. So let's compare your answers and see how you did. For example 1, you should have gotten n was greater than 8 or n was less than 4. On the graph, you should have open circles on 4 and 8 with shading going in the opposite direction. For the second example, you should have gotten x was less than or equal to 7 or x was greater than 9. You should have a closed circle on 7, an open circle on 9, and the shading going in opposite directions.